Hi everyone, welcome to math class. Today what we're working on is rate problems with fractions. So we're working on computing unit rates with ratios of fractions. So we've been working a lot with ratios of whole numbers, and now we're going to look at ratios with fractions. So the question that we're trying to answer, and what I want you to start thinking about, is if you had 1/3 of a gallon of paint and it covered 1/9 of a gate, then how many gallons of paint is needed to cover the entire gate? Who knew that painting a fence could get so complicated? The learning objective for today, students will be able to find the unit rate from a ratio of fractions and know how to work with complex fractions. So in order to do this, we need to review what is a rate. A rate is a ratio that compares two quantities with different units. Miles per hour, feet per second, dollars per pound. Those are different rates or different units. There's a comparison of two quantities with different units, and that's what a rate is. So for instance, I could say I traveled 120 miles in 2 hours. That is a rate. Talks about how many miles I can travel in 2 hours. But a unit rate is a rate whose unit is 1. So how many per unit? So to find a unit rate, or how much per unit, remember we write the rate as a fraction. So we'd had 120 miles over 2 hours. And then we want to rewrite the fraction so the denominator is 1. How do we get that to 1? We're going to divide by 2. Which means we divide this by 2 and we get 60. So in this case, we have 60 miles that we're traveling in 1 hour, or per hour, which gives us our unit rate. The other thing that we need to review for this lesson is we need to remember how to divide fractions. So dividing fractions, remember, was a tricky concept, and it was so much easier just to multiply them. So the way that we do that is we learned keep, change, flip, which means we multiply the fraction by its reciprocal. So in the event that I had 1 over 2 divided by 2 over 4, I'm going to multiply by the reciprocal, which is keep, change, flip. The first fraction is going to stay the same, 1/2. I'm going to change that sign and make it a multiplication sign, and then I'm going to flip that second fraction, so I'm multiplying by that reciprocal. And then I just multiply straight across. Alright, so keep, change, flip was what we learned with our when it comes to dividing fractions. So let's go back to our original problem of 1/3 of a gallon of paint covers 1/9 of a gate. So how many gallons of paint is needed to cover the entire gate? So we're going to need to divide that total amount of paint. Here's our total amount of paint. And we're going to divide by the given portion that it covers, the portion of the gate that it covers. So we can set this problem up like we would any other ratio. What we already know is that when we deal with ratios with whole numbers, let's just use that same problem using whole numbers, and let's say 3 gallons of paint covered 1 gate, then our ratio would be 3 to 1. So that we could write that as 3 over 1. But now we're using 1/3 of a gallon, which covers 1/9 of the gate, so the ratio is actually 1 over 3 to 1/9. Or you can write it just like I did here as a complex fraction. 1 over 3, fraction bar, 1 over 9. So our 1/3 of a gallon covers 1/9, and we've written it as a complex fraction. The ratio is a complex fraction. To complete a fractional division problem, this is a fractional division problem. Remember that fraction bar means division. So as a fractional division problem, we follow the steps for dividing fractions. So we turn this from a division problem into a multiplication problem by multiplying by the reciprocal, or we use keep, change, flip. So let's set it up. We know this is what our problem is, 1 over 3 divided by 1/9, and we're going to go ahead and keep, change, and flip to multiply by the reciprocal. And then we just multiply straight across. 1 times 9 is 9, and 3 times 1 is 3. And looking at this, we can see that our end result is that it will take us 3 gallons of paint to cover the entire gate. Let's look at this using a tape diagram, or look at it, model it, so you have a visual representation of the same problem. 1/3 a gallon of paint covers 1/9 of a gate. Then how many gallons is going to cover the entire gate? And let's just set that up. We're going to put the gate divided into ninths. I'm going to divide it in ninths because that's what our problem is telling us, that the gate, we have ninths, that's what the paint is covering. So I went ahead and divided my gate here into ninths. Okay, so I have 9/9 would make my whole gate. And then I know that I have 1/3 of a gallon of paint is going to cover one of those ninths. So there's 1/3 of a gallon of paint. So for every ninth, it's going to take me another 1/3 of a gallon of paint. These are in proportion. They change at the same rate. So 1/3 for another ninth, 1/3 for a ninth, and so forth and so on until my entire gate is covered. And now that I've covered my entire gate, I need to know how many gallons. So looking at my gallons of paint, for every 3, 1/3, 1/3, 1/3, that gives me 1 full gallon. And so again, I have another 1, 2, 3, which is going to give me another gallon, and 1, 2, 3, which is giving me another gallon. So when I look at this, I have 1 gallon plus 1 gallon plus 1 gallon, so it's going to take me 3 gallons of paint to cover the entire gate. All right, so let's work on one without, let's work on one real quick. Let's take a look. Jackson eats 1/4 part of a banana in half a minute. How much time will he need to eat a full banana? So again, we're going to set this up. We're going to divide the total number of minutes, which is 1/2, and we're going to divide that by the amount of eaten banana, 1/4. So I wrote it here as a complex fraction. And then I'm just going to complete this fractional division problem by following the steps for dividing fractions. I'm going to turn this from a division problem, 1/2 divided by 1/4, into a multiplication problem by multiplying by the reciprocal, or doing the keep, change, flip. And when I do that, I multiply straight across. 1 times 4 is 4, and 2 times 1 is 2. So we wind up with 4 over 2, which equals 2. So it is going to take 2 minutes for Jackson to eat the entire banana at the rate of 1/4 banana for half a minute. Okay, so let's take a look at another one. Mike ran half a mile in each 1/7 of an hour. So compute the unit rate, the miles per hour, as the complex fraction. So let's set up our problem again. There is half a mile every 1/7 of an hour. So divide the total miles run, half, by the amount of time, 1/7. We're going to do the same thing, complete a fractional division problem. We're going to follow the steps for dividing fractions. We're going to turn this from a division problem, 1/2 divided by 1/7, into a multiplication problem by multiplying by the reciprocal, or we're using keep, change, flip. So when we do this, 1/2 divided by 1/7 becomes 1/2 times 7 over 1. And we just multiply straight across. 1 times 7 is 7, and the 2 times 1 is 2. And then we're going to go ahead and change this into from an improper fraction. 2 goes into 7. How many times? 3, 6. We have 1 left over. So we're going to bring down the 0, add a decimal. 2 goes into that, 5, 10, 0. So we know that Mike ran half a mile in each 1/7 of an hour, so he is actually running 3.5 miles per hour. All right, here's another one. Alyssa made 1/5 of a batch of cookies in 1/10 of an hour. So how many batches of cookies can she make in 1 hour? All right, so she did 1/5 a batch of cookies in 1/10 of an hour. And we're going to do this the same way to solve a fractional division problem. We're going to write it out as a division problem, 1/5 divided by 1/10. And then to solve that, we have to do keep, change, flip, or multiply by the reciprocal. So we keep the first fraction, and we change the sign to multiplication, and we flip. We multiply by the reciprocal. And when we do that, we get 10 and multiply 5 times 1 is 5. Looking at this, we know that Alyssa is making 2 batches of cookies in 1 hour. 2 batches per hour. Here we go. Okay, so ratios with complex fractions are really not all that hard. We just need to remember to treat them the same, write them as a complex fraction, and then divide. And remember, when we're dividing a fraction by a fraction, we multiply by the reciprocal. So we do keep, change, flip. Make sure you get that in your notes because we'll be doing lots of ratios with complex fractions this week. All right, take care, and we'll see you in math class.